Welcome back to Topic 9 for Algebra 1, Solving Absolute Value Equations. In Part 1, we're going to first learn what is an absolute value equation and solve a few simple examples. So what does an absolute value mean? For instance, if we have the absolute value of a just being any number, that means the distance from our number a to 0. So if we think about this on a number line, let's mark 0 in the center, and then on the right-hand side we have positive a, and on the left-hand side we have negative a. Now if we were to think how many jumps would it take for us to get from a to 0, it would take us a jumps, a spaces. What about if we were going from negative a to 0? If we were counting towards 0, we would still jump a spaces. Feel free to substitute in for a such like positive 3 and negative 3. If we jump from 3 to 0, it takes us 3 spaces. And if we jump from negative 3 to 0, it's also 3 spaces. That being said, if we have the absolute value of 8, that's saying the distance from 8 to 0 is 8 spaces. The distance from negative 8 to 0, or the absolute value of negative 8, is also positive 8. So the absolute value of something is always equal to a positive number. So in our example here, we have the absolute value of x equals 7. So what are some possibilities that x could equal? Well, inside my absolute value, I could have positive 7, because the absolute value of positive 7 gives me 7. I could also have x equaling negative 7, because the absolute value of negative 7 equals 7. So again, all I'm doing is just substituting what value could I plug in for x inside of my absolute value signs here. Think about your absolute value symbols as like posifying the value that's inside of them. Now in our second example here, we have the absolute value of x equals 0. Now here, this is just x equals 0, because 0 is neither positive nor negative. So I can't have one positive value and one negative value. If I have the absolute value of x equals negative 12, here we do not have a value for x, because the absolute value of something cannot be negative. It cannot equal a negative. So if we go through our first example here, the absolute value of x equals 7, this is the same thing as saying that there are two solutions. We had positive 7 and negative 7 that we could plug in for x. Whenever we have the absolute value of x equaling 0, we can expect one solution, because again, 0 is neither positive nor negative. And if we have the absolute value of a number equals a negative number, this is no solution, because the absolute value of something must always equal a positive number. Let's try a few examples. Here we have the absolute value of the quantity x minus 3 equals 8. So in my absolute value here, this whole quantity, I could either plug in positive 8 and get out positive 8, or I could plug in a negative 8 and get out positive 8. So whenever we have our absolute value alone, we're going to split. We have x minus 3 could give me positive 8, so that entire value in my absolute value could give me positive 8, or x minus 3 could give me negative 8, because remember, the absolute value of negative 8 that we would plug in there gives me positive 8. Now what we just have is a linear equation, and we're going to solve for a variable, solve for x. Here we see subtraction, so the inverse of subtraction is addition. We're going to add 3 to both sides. Now it's the same for both equations, so I'm just going to repeat this process alongside. Negative 3 plus 3 gives us 0, so we're just left with x equals. With our first equation, 8 plus 3 gives us 11, and our second equation, negative 8 plus 3 gives us negative 5. So these are our two answers. Now to check to make sure that we did our math correctly, we're going to plug back into the original equation, also known as a check step. I know, all of your favorites. So let's say we have the absolute value of 11 minus 3 should give us 8. Well, the absolute value of 11 minus 3 is 8, and the absolute value of 8 is positive 8. Perfect. Now if we have the absolute value of negative 5 minus 3 equals 8, well, we know the negative 5 minus 3 is negative 8, and the absolute value of negative 8 equals 8. With our next example, we have the absolute value of 4n minus 6 equals 18. So again, what can this value that we have inside of our absolute value symbols equal to spit out a positive 18? This quantity, 4n minus 6, could be equivalent to positive 18, but it could also be equivalent to negative 18. Here we have a two-step equation, just like we did in topic 3. So we're going to add 6 to both sides since we see that subtraction, so we want to apply the inverse. It will cancel on the left-hand side, and we're left with 4n equals 24, and 4n equals negative 12. Here we have 4n, which is 4 times n. The inverse of multiplication is division, so we're going to divide everything by positive 4 to isolate that n. On the left-hand side, 4 divided by 4 is 1, so we're just left with n. 24 divided by 4 gives us 6. Negative 12 divided by 4 gives us negative 3. Now we can plug back in to check our work. So we have the absolute value of 4 times 6 minus 6 should give us 18. We know that 4 times 6 gives us 24, and 24 minus 6 gives us 18. So the absolute value of 18 does equal 18. In our next example, in order to check, we're going to plug in negative 3. So we have 4 times negative 3 minus 6 equals 18. 4 times negative 3 is negative 12. Negative 12 minus 6 gives us negative 18. And the absolute value of negative 18 equals positive 18. So we are set there, and those two solutions are valid. Thank you for watching part 1 of topic 9 for Algebra 1 on solving absolute value equations.